A very good morning, good afternoon, and good evening to all. So, this is Suvendu, your physics mentor, and in today's class, we will discuss one of the best question related to light. Okay. So, basically, आज आमे लाइट कॉन्सेप्ट रो गोटे क्वेश्चन करिवा जोटा कि टोटल इंटरनल रिफ्लेक्शन उपरे बेस्ड अछि. Now come to this question. I will explain this question in a very simplest manner from theory to numerical. So this question is asking a light ray is incident perpendicularly to one face of a 90-degree prism and is totally internally reflected at the glass air interface. If the angle of incidence is 45 degree, we conclude that the refractive index. So these are the options: n greater than 1 by root 2, n greater than root 2, n is less than 1 by root 2, and n is less than root 2. n is the refractive index that we have to calculate. देखो डायग्राम को देखिए दरकार. दिस इज आवर इंटरफेस. दिस रेड कलर लाइन is our, as per the question, it is our glass air interface, this red color line. Okay, first आगे सुनो total internal reflection concept रे कौन सब ट्रिक अछि. So first thing, this is suppose our interface and you listen, this is suppose the normal and the lower medium is our denser medium suppose, and let this is your rarer medium. So let's consider light travels from denser to rarer medium. So we know when light travels from denser to rarer medium, refracted ray moves away from normal. So in this case, this one is angle I and this one is angle R, angle of refraction. ये बहुत सिंपल क्वेश्चन, ठीक से सुनो था. सो व्हेन लाइट ट्रैवल्स फ्रॉम डेंसर टू रारर मीडियम, रिफ्लेक्टेड रे मूव्स अवे फ्रॉम नॉर्मल. से टाइम आम कौन करवा, एंगल ऑफ इंसिडेंस टा टिके इंक्रीज करवा. सो व्हाट विल हैपन ऑन इंक्रीजिंग द एंगल ऑफ इंसिडेंस, व्हाट विल हैपन नाउ सी. On increasing the angle of incidence, the angle of refraction also increases. But this is angle R, this is angle I. Okay, if you will continue this process, then what you will observe, now see, this is the normal. On increasing the angle of incidence again, so for a particular angle of incidence, the refracted ray travels through the interface. This white color line, basically this is our interface. Okay, this is our refracted ray. So here this is angle of incidence and angle of refraction is 90 degree. Okay, this particular angle of incidence is called critical angle C. So critical angle concept रे कौन सिखिले हमें. So when light travels from denser medium to rarer medium, in that case, for a particular angle of incidence, the angle of refraction is 90 degree. That angle of incidence specially termed as critical angle. Again कौन करिवा, on increasing the angle of incidence further, that means बर्तन देखो आम कौन कले, एंगल ऑफ इंसिडेंस को अगेन इंक्रीज कले. थर्ड केस कौन थी रे, एंगल ऑफ इंसिडेंस इज कॉल्ड क्रिटिकल एंगल. सो इन फोर्थ डायग्राम ये तुम एंगल आई इज ग्रेटर देन सी. बस से टाइम कौन हम तुम कौन लाइट स्टार्ट्स टू रिफ्लेक्ट टू द सेम मीडियम. ओके, सो दिस इज आवर एंगल ऑफ रिफ्लेक्शन आर. हियर एंगल आई इज इक्वल्स टू एंगल आर. ए फोर्थ डायग्राम टाक आम कहवा कॉन्सेप्ट ऑफ टोटल इंटरनल रिफ्लेक्शन. टोटल इंटरनल रिफ्लेक्शन. ओके ए थर्ड डायग्राम को आम कहवा ग्रेजिंग इमर्जेंस फर्स्ट सेकेंड डायग्राम that is your basically refraction concept okay बस so in case of grazing emergence जदि हम grazing emergence टे भलसे आउथरे करवा बुझिबा let this is our interface this is suppose your normal and this is your denser medium and this is your rarer medium let refractive index of denser medium is n denser and refractive index of rarer medium is n rarer bas so when light ray travels from denser to rarer the angle of incidence when it is equal to critical angle then refracted ray passes through the interface in that case angle r is equal to 90 degree bas এই কেসে আমি যদি আমি অ্যাপ্লাই করিবা কোন স্নেলস ল হোয়াট ইউ উইল গেট নাও সি refractive index into sin of this equal to refractive index of error into sin of r as per Snell's law. So as per Snell's law we will get n denser into sin c is equals to refractive index of error into sin r that is 90 degree. Sin 90 is 1. So we can write refractive index of denser into sin c is equal to refractive index of error. That means sin c value is equals to refractive index of error medium divided by refractive index of denser medium. Always keep this formula in your mind. Sin c is equals to refractive index of error medium divided by refractive index of denser medium. Now we will apply all these concepts in this question. Now see it. This red color line represents our air glass interface or glass air interface. Okay, that means এই portion number কোন হইছি total internal reflection হইছি. Here in this figure which is your angle of incidence I is equals to 45 degree as per the question. So question अनुसारे हमें काम करिवा देखो. So as per the question total internal reflection is given. So for total internal reflection कौन कही concept for total internal reflection angle I should be greater than critical angle सेतिक जिनस खाली लिखा हबार अछि. So as total internal reflection occurs at glass air interface that means we can write angle I is greater than angle C which implies sin I is greater than sin C. Plus, so here angle I is 45 degree. So sin 45 degree is greater than. Plus, now tell what is sin C? Refractive index of error divided by refractive index of denser. So rarer medium is our air. So refractive index of air divided by refractive index of glass. So sin 45 is 1 by root 2 is greater than air refractive index is 1 and as per the question refractive index of glass is n. So upon cross multiplication we can write n is greater than root 2. So this is our answer. Our answer is B is our correct answer. Okay. କିଛି ନାହିଁ ତମେ ଖାଲି ଜାଣିବା ଦରକାର what is the concept behind your total internal reflection. Okay. So এই question को solve କରିବା ପୂର୍ବରୁ ଏ theory part को ଭଲସେ ଆଗ ଶୁଣ. How to apply Snell's law in this question. Okay. Thank you. या आगକୁ ଏମିତି ଭଲ ଭଲ question ମୁଁ ଆଣିବି. Okay. So stay tuned for next update. And please like, share and subscribe my channel. Thank you. Have a nice day.